So I don't know how the homework went for you yesterday, but I'm guessing you might have trouble with number 13. I am not going to do it for you. I would like you to contact me if you're having trouble with that one. It's a good way for me to figure out if you're actually doing your homework. All right? We'll talk about that one because that's a bit of a tricky one. If you don't know what you're doing, you might want to ask about it. Okay? Let's change pace a little bit here. The unit is called permutations and combinations. Combinations are similar to permutations, but a little bit different. Let me explain. So here it says, in how many ways can 3 people be chosen to sit on a committee? Chosen is kind of a hint word. To sit on a committee from a group of 5 people. So let's think of those 5 people as being A, B, C, D, E. There's 5 people. Okay, now I'm going to pick 3. You tell me if you think these are different groups. Is this a different committee? Sure it is. There's different people on that committee. These 3 are different than these 3. Okay, but how about this? Is ABC different than ACB? Okay, let's get rid of this one here. Are these 2 committees different? No, they're the same committee. Okay, so this is where combinations come into play. Combinations doesn't care about the order, right? Like if I'm going to work with these 3 people, or let's say you're going to take 3 books along on a trip, or you're going to buy 3 items from the grocery store, it doesn't matter the order you buy them in as long as you're buying them. Okay, so combinations, the key is that order is not important. All right, a permutation, the order is important. All right, you should make sure you understand that difference. Okay, so let's try looking at combinations. So first of all, a little bit of sort of definitions here. Just like we had that button NPR, we also have the button on the calculator NCR. And you can see the formula is a little bit different. This is the permutation formula, but you're also going to divide by R factorial for combinations because that eliminates the fact that, you know, if you have ABC and ACB, these are not different. So by dividing by R factorial, it gets rid of the repeats. Okay? One other thing that you should know is that NCR can also be written like this. Okay, it reads N choose R. Okay, we're choosing them, not permuting them. Permuting them means to arrange them. So the difference is about order. Okay, so let's try a couple with the calculator here. Again, you should be able to do these both ways. So the first way is just finding the button on your calculator. 5, choose 3. The second way is to use the formula. So it would look like this, which is 5 factorial over 3 factorial, 2 factorial. Okay, and then I can do this without a calculator. So those cancel out, and so I get 10. Okay, if you want to try your calculator, see if you can find that button. It should be very close to the NCR button. So 8 choose 4, you can do it 70 times. How many ways can you choose 1 from 7? 7. How many ways can you choose 0 from 6? 1. Okay, so let's take a look at some examples now. In a Keno lottery, there are 20 numbers from 1 to 80. Again, you have to decide here, is this a permutation or a combination? Now, this lesson is about combinations, so these will be combinations, but you need to understand why. Okay? It even uses the word combinations here. That's a hint. The word chosen is a hint, but let's understand this. So if we're supposed to pick 20 numbers from 1 to 80, for example, if I pick these numbers, 1, 5, and 10, what if I went 10, 1, and 5? Have I picked the same numbers? Yes. Order here doesn't matter, so we're just trying to choose them. So out of the 80 numbers, we want to choose 20 of them. So that one I definitely want to use a calculator for because it's a little bit of a big number. So here's what my calculator says, 3.5, 3, 5, 3, 1, 6, 1, 4, 2. And then it says e to 18. What does this mean? If you leave that in your answer of the test, you will not get the right answer. This means 3.535316192. This means times 10 to the power 18. In other words, we should move this decimal 18 times this way. Okay, so it's a pretty big number. That's scientific notation. Okay, let's do one that's a little closer to home here. Lotto 649. You guys know anything about Lotto 649? That's a lottery that happens in Canada. In Lotto 649, there are 49 numbers, so the numbers 1 to 49, and you choose 6 of them. Again, order doesn't matter here. Okay? So 49, choose 6. And this is interesting. Just to put this in perspective, so this is about 14 million possibilities. Lotto 649 usually pays out a couple of $1 million. So if you wanted to buy every single possible ticket, you would have to buy 14 million tickets. They cost $1 each, I think. That's $14 million, and they pay out a couple of million. So you can see why Lotto 649 makes a lot of money for the provinces. Okay? More likely, the combination questions will have to do with applicants and filling a job. Okay, so here it says there are 10 people that apply for a job, and you want to pick 4 of them. Again, the hint word there is chosen. This is 10, choose 4. Okay. So there's 210 ways you can pick 4 people. It does not matter the order you pick them. It just means that that's how many different combinations you can have. Okay? Now here's something that for some reason this course really gets hooked on. If I go 10, choose 6, it's also 210. Okay? And the question is, why are those the same answer? Okay? It has to do with the formula. What is 10 choose 4? It's 10 factorial over 4 factorial over 10 minus 4 factorial. Okay? And if you simplify that, you get 10 factorial over 4 factorial, 6 factorial. If we go down here and say, what's 10 choose 6? This is going to be 10 factorial over 6 factorial over 10 minus 4 factorial, which is 10 factorial, 6 factorial, 4 factorial. And this is why they're the same. In fact, any time these numbers equal how many you're choosing from, you're going to get the same answer. So for example, 7 choose 3 and 7 choose 4, because those add up to 7, they'll be the same. 15 choose 4, 15 choose 11, because those add up to 15, they're going to be the same. Okay, just something to keep in mind. There are a few questions where that comes into play. All right, next. A new store must hire 3 cashiers and 4 stock clerks. What does the word "and" mean again? And means multiply. Okay, so keep that in mind. So there are 7 applicants for cashier and 8 for store clerk. How many ways can 7 employees be chosen? So we're supposed to choose 3 cashiers, 4 stock clerks. Okay, so cashiers and stock clerks. Okay, how many ways can I choose a cashier? Well, 7 applied, and I'm supposed to hire 3. And means multiply. Stock clerks, there are 8, and I'm supposed to pick 4 of them. Choose 4. Doesn't matter what order again. Okay, so 7 choose 3. That's 35 times 8 choose 4. I think we just did that up here. What was 8 choose 4? 70. So 35 times 70. So this is 2,450 ways. Okay, this is a common type of a question where you have to do two things and you have to combine them like that. Okay? All right. Now we're getting into the real tricky ones. This is a teenager problem right here. This is such a classic situation. So June is having a party. Hey, for Pi Day, of course. She has a total of 9 friends, but she can only invite 5 to the party. The problem is Sam and Cole do not get along. See, you know what happened here, right? Sam used to go out with this girl, June, and now Cole is, and so these two guys hate each other. Classic teenager problem, right? Okay, they don't get along, so they can't be at the party together. How many ways can you invite people to the party? Well, what are some options? We could invite neither of them. Let's not invite Cole or Sam and not worry about it. Or, by the way, what does the word or mean? That means plus. What could we do? We could invite Sam. This would mean that we wouldn't invite Cole. Or we could invite Cole and not Sam. So if we invited neither, how would you do that? Well, she has 9 friends. If we take away Sam, take away Cole, how many friends does she have? 7 friends, and she is going to invite 5 of them. Or, all right, if you're inviting Sam, that means you're choosing him. Now, you don't need to write one, choose one, but that means you're choosing Sam. Okay? Then how many people are left? So now Sam is coming, but Cole is not. So now there are how many other people? 7, right? It's the 9, take away Sam, take away Cole. There's 7, and how many is she going to choose from those 7? 4 more, because 1 and 4 equals 5. Now you're doing both of these things, so we need to multiply here. Okay, it's Sam and these 4 others. Or, okay, we're going to invite Cole, and then 7 other friends, choose 4. Okay, so 7 choose 5. I think that's 21. Let's quickly check. Yeah, 21 plus 7 choose 4. I think that's 35. Plus 7 choose 4. I think that's 35. And so you get 91 ways to invite your friends. Now you know, next time you have a party when we're done with this, now you know what to do. Okay. And the last one. I think this, oh no, there's 2 more. Okay, let's talk about this. There are 6 men and 7 women eligible to sit on a committee. They must have 5 members. Okay, so we're going to choose 5. If there were no conditions after this, so if we had nothing else happening, it would be 13 choose 5. Right? There's 13 people and we're choosing 5. Okay? But it is not saying that. It says at least one of them must be a man. At least one of the 5 has to be a man. So how many men could there be on 5 members? Well, at least one man means we have to have 1. Or 2. Or 3. Or 4. Or 5. Okay, so let's think about it. If we're going to choose 1 man, this would be 6 choose 1. And now we have to fill up the committee with women. 7 choose, how many more do we need? 4. Okay, now if we want 2 men, how would you do that? You'd go 6 choose 2. And 7 choose 3. Again, it has to add up to 5. Or 6 choose 3. 7 choose 2. Or 6 choose 4 and 7 choose 1, or 6 choose 5, 7 choose 0. Okay, now you can do it that way. That works. Nothing wrong with that. But there are lots of calculations. It's possible that you get something wrong. But that's option 1. Let's try another way. Okay, what's the other way? Well, we need to have at least one man. What's the only thing we can't have? 0 men. 0 men is not going to work. How would I figure out 0 men? You would go 6 choose 0 and 7 choose 5. This is how you would choose all women. Okay, but this is what we don't want. So what we do want is, let's take away what we don't want from all possible. Okay, now I said the all possible way was 13 choose 5. That's all the possible combinations. And if we take away what we don't want, okay, this is what we don't want to have, this should give us the same answer as that. Okay, so let's quickly try those. If you could take a couple of minutes to try them, see what your answer is. So this is 1287, take away (21) equals 1266. So I think those should both equal the same thing. All right, that's a common question, this idea of at least. Okay, make sure you try a couple of those. And last, let's solve for n here. We're going to use the formula. So this is n factorial over 2 factorial, n minus 2 factorial. This is equal to 21. Okay, how do we do this? Well, we simplify, right? Which one of these is bigger? Is it this or this? The top one is bigger, so we're going to reduce that one. So this cancels. Okay. By the way, make sure you keep it an equation. So then you have n times n minus 1 equals 42. Then let's bring everything to one side of the equation. So you get n minus 7, n plus 6. So n is 7 or negative 6, and again, we can't have a negative value for n. All right, that is the end of permutations and combinations, sort of. So I'd like you to do page 719, 4 to 10. And page 727, numbers 4 to 7, 9 to 16. Okay, we'll do those, and then we'll get into the very last lesson of the year. All right, good luck.